with your questions or your comments at the tail end of this presentation. So once again, let's prepare to gain insights on not only how we can enhance compliance and even our accreditation efforts, but also how we can build a culture of continuous improvement and our environments to be free from harm. So with that, Agri, I'm sure you can hear me. You can just confirm that you can hear me.
Yes, Fred, I can hear you clearly.
Very good. So you can go ahead and proceed.
Thanks a lot, Mr. Friend. I really appreciate for that introduction. And today we are going to learn Fmea, that's failure mode and effects analysis. So you are welcome on board. Each and every one of you who is participating in this presentation, you are welcome so that we learn together, so that we ensure that we practice well in this profession. So you are all welcome on board. We are going to look at this Fmea in clinical laboratories. And also at the same time, we are going to look at how, in particular, how Fmea or Fmea is applied in clinical laboratory and risk analysis and prevention. So we are, in a nutshell, this is what we are going to look at. So in this overview, there are points that we are going to look at. We're going to, after the introduction, we are going to look at mode, failure mode and effects analysis, the definition of Fmea. Next, we are going to look at step by step through Fmea. When are we supposed to use Fmea? It's another question that we need to ask ourselves. And also, we're going to look at steps and activities in Fmea and hierarchical ratings of skills, of risks and problems solving. We're also going to look at key benefits of Fmea in clinical labs. So we are going to look at these points. For me, I'm going to term it as Fmea, that is failure mode and effects analysis. So in a brief introduction, we should know that timely delivery of correct results has long been considered as a goal of quality management in clinical laboratory. With an increasing workload as well as complexities in the laboratory testing and patient care, the traditional technicalities that are adopted, like internal quality control and external quality assessment, TQA, may not be enough to cope with the quality management problems for clinical laboratories. We are going to consider the failure mode and effects analysis as a proactive tool in this, because IQC and EQA are not enough. Even QA is not enough if we don't incorporate Fmea in our operations. So Fmea is a proactive tool, and in this, we have to predict and preempt or anticipate possible pitfalls or potential future errors on certain procedures, methodologies, policies, etc. And this is geared towards reducing errors associated with the process, beginning with sample collection and ending with a test report in clinical chemistry lab. However, although I've quoted about clinical chemistry laboratory, all the laboratory sections across board need to apply Fmea in their operations, because apart from clinical laboratories, Fmea is used somewhere else in various places in industry, can be in engineering, It can be in various organizations and managerial situations in various places. But now for us, we are going to talk about how it's used in clinical labs, not only particularly in clinical chemistry lab. Failure mode and effects analysis. What is this in definition? So failure mode effects and effects analysis, I will call it Fmea, is a structured way to identify and address potential problems or failures of laboratory equipment and the resulting effects on the system or process before an adverse event occurs. So in this Fmea also, we are going also to consider not only equipment, we are going to consider also systems. We are also going to consider processes in the laboratory because it can involve processes, it can involve other issues altogether, not only equipment, but majorly lies on equipment when you're talking about clinical laboratories. But in quality management systems, we can also consider other systems and processes in the laboratories. We are going to look at these highlights, especially on analytical problem question. Failure mode and effects analysis can be applied to reduce error in laboratory. Most of high-score failure modes appear in pre-analytical phase. Laboratory errors can be reduced and controlled in Fmea. That's what we need to know, that these errors can be controlled. So how is root cause analysis compared to Fmea? It's a question that we need to ask ourselves because we often follow the root cause analysis, especially when problems have occurred already. And now we are in a reactive mode so that we can solve the problems that have already occurred. But now in Fmea, we are going to look at it, how Fmea is different or how is it related to root cause analysis. So in comparison, root cause analysis is a structured way to address problems after they occur. Fmea involves identification and elimination of process failures, the process of preventing undesirable events. Then when are we supposed to use Fmea? Fmea is effective in evaluating both new and existing processes and systems. So we can use it when we are introducing new processes, we are introducing new systems. New processes can be procedural, can be technical. Yeah, they can come in various angles. So we can use it in in existing processes and systems, or in new processes and systems. For new processes, it identifies potential bottlenecks or unintended consequences prior to implementation. It's also helpful for evaluating an existing system or process to understand how proposed changes will impact the system. Once you have identified what changes need to be made on the process or system, the steps should be taken to make checks and balances that are preventive in nature. So you learn so many things pertaining to a process or a system and potential failures or redundancies and potential risks of certain processes or procedures and systems before you begin even operating on them or before even you introduce them. And procedures and processes can come midstream in the operation of a certain process or an equipment. So it's a one process introduced upon another. And also in this, you can apply Fmea protocol in addressing such introductions. We are going to look at a guide through the Fmea process so that we can also use this guide to walk through this process that we are introducing or we are that have come midstream so that we can prevent future occurrences of incidences that are against our precedents, against our planning. The Fmea is a tool that will allow clinical laboratories to proactively identify and reduce potential failures within an existing or proposed laboratory process. Fmea is very similar to what most people do every day. We try to anticipate what might go wrong and do what we can to prevent this from happening or minimize the effects. For instance, I will give an example. Let's say you've woken up early in the morning and you want to go to work. And in the news, you've heard that you've watched news concerning a certain problem occurring in a certain place headed to town. Maybe you in your mind, you set in your mind that you're not going to follow a regular route, the routine route that you use to town. And you devise a plan that you are going to pass through certain streets so that you can reach your final destination. And this is this a potential process that you've defined so that you can prevent entering into an incident because of what is happening, what you've watched on television that is happening on the normal route that you usually follow to your workplace. So to prevent these incidences, you might do various things, either to change the routes or to comply with what is needed during this maybe fracas that's happening around. You are able to comply and also get away with such problems, especially what might be encountered along the way. So you plan ahead. Are you able to walk? Sometimes you can walk so that you can evade such problems, maybe road barricades or something like that. Yes, maybe are you going to change your attire so that you cannot be identified? So these are things, the steps that you are taking to prevent an incident that's going to occur along the way. You can avoid certain certain route. You can change certain things so that you can be safe. And this, we're going to look at what is applicable in clinical laboratories. For instance, in a clinical lab, you anticipate that an analyzer might fail at some point if not maintained regularly. Then set it as a policy in standard operating procedures to do the following. Before running tests in your analyzer, as you start any shifts, you have to decide to check and do preventive maintenance. Do calibrations where necessary. Check on the expiry of reagents. Check on power systems. You can run controls to ascertain that everything is in good state for you to run the test with maximum efficiency. These are but among things that you can do so that you can ascertain that everything is going to be right when you're operating that equipment. By knowing what might go wrong, you might make changes that reduce or prevent something from happening or from going wrong. We are going to look at steps in Fmea, and we're going to check the steps involved in the failure mode and effects analysis. First, you select a process to analyze and choose a process that is known to be problematic in your facility, one that is known to be problematic in many facilities. So you can check in your facility, and also you can check in other facilities, other comparable facilities, the potential problems that might be there. So you also check the team coordinator and the team members' leadership, and continue to brainstorm and analyze and come up with action points and policies. The third point is that you describe the process clearly, then define the process steps so that everyone on the team knows what is being analyzed. So these are collective work. This is a teamwork. So it should create a way that everyone is playing a role. Everyone plays a role in this Fmea process. Next, in Fmea steps, you identify what will go wrong during each step of the process. Here is where people are directly involved in the process, describe the problems that can occur or do occur. Pick which problems to work on and or on eliminating. Yeah, big problems to work on, and you can use also eliminating policy. Focus on improvements that will be on those problems that happen quite often, and or have a significant impact on patient safety. So there are problems that can happen quite often, and there are problems that can impact heavily on patient safety. So consider the two, and consider either one of the two or both due to the nature of the problem. So this is what falls under the category of processes called risk analysis in the laboratory. So we cannot talk about risk analysis without talking about Fmea. So you assign rankings for severity of the case, and then you can label it as S. Occurrences, and these are frequencies of occurrence. You can you can assign with the letter O, and also detection. How often is it detected? Yes, it can occur, but how often does it get detected? Calculate the risk priority number, the RPN, or action priority, to prioritize risks. Next, in Fmea, we design and implement changes to reduce and prevent problems. The team, now here is the team. Here is where the team determines how best to change the process to reduce the risk of inconsistent results and misdiagnosis from the laboratory. Next, that is step number 7, is to measure the success of the process. Like all improvement projects, and success of improvement action is evaluated. So these are basically 7 steps in the failure mode and defects analysis process that we should put in place when we are beginning a new process or introducing a new methodology and new policies, SOPs, and so many other things that pertains to the lab. There are also key activities in Fmea process that we are going to look at. And these are planning and preparation, define the scope, the system boundaries, and establish the cross-functional team in order to oversee the implementation of a process. Then you have to do what we call structure analysis. In structure analysis, you have to break down the system and subsystems or processes. In these processes, you have steps to understand, and you need to understand the relationships of these steps. Now, after understanding their relationships of the steps, having broken them down into their subcomponents or subsystems, you analyze what we call a function. It's what we call function analysis. In function analysis, we define the intended functions and requirements for the system or process. Then we look at failure analysis. Identify the potential failure modes, how it could fail, their effects on the customer, and root causes. Then we look at risk analysis. Assign rankings for severity. You rank the severity of these risks. Severity, we can use letter S. Occurrence, we can use letter O. Detection, we can use letter D. Calculate the risk priority number or action priority number. So there is a formula that we use to do risk analysis. I've not put it there, but it's risk analysis equals to severity times occurrence times detection. So you multiply the three, S, O, and D, to get the risk priority number. In risk analysis, you multiply, you calculate the risk priority number by multiplying severity and occurrence and detection. Now, after getting the risk priority numbers, you optimize the process. You optimize the method or the system. You develop and implement corrective actions to reduce high-risk failures. So high-risk failures you have to be reduced first, followed by other medium risks and low risks. This includes updating controls and re-evaluating risk levels and eliminating the causative agents of these happenings or risks. Then you document the results. Document the entire analysis, including actions taken and the residual risks for future reference and continuous improvements. So documentation is also key in Fmea. So you should consider that so that you can follow up on things that matter. Because if you don't, you are not able to follow up on things that happened, you are not able to solve any problem or any problem that is at hand or any problem that is upcoming in future. What about gaps, risks, and patient safety question? You can use Fmea to examine processes in any of these areas to proactively reduce risks to patient safety and improve quality and care, quality of care and quality of life for residents. And residents, you see, we are handling an ecosystem. We are not only dealing with patients, we're also dealing with service users. We're dealing with stakeholders, and these stakeholders can be varied. Stakeholders can be patients. Stakeholders can be our proficiency testing providers, the PT providers, who usually handle our EQA, govern our EQA processes. Our service, the The stakeholders can be physicians, they can be also other clinicians, who are interested in our results. The stakeholders can be even the government, because we are usually regulated by KMTB. There are laws that govern us. So, we use Fmea to make sure that we are safe, and also our stakeholders are safe too, and also our stakeholders are satisfied with us. When conducting Fmea on an existing process, consider selecting a process that is known to be a problem or to be problem prone or potentially risky. That's why we use risk priority numbers, the RPMs that we've seen in previous slide. For instance, do staff members consistently perform routine equipment preventive maintenance? In Fmea, we can use to identify gaps and develop actions to make the process more efficient and safe. We begin to solve problems before they occur for us to be safe, but not vice versa. We don't, many people wait for problems to occur so that they can solve them, but that is a wrong approach. So in medical laboratory, we need to solve problems before they occur. And this is why we need to apply Fmea process. Fmea also helps to prepare for implementation of new processes with minimal errors, failures, or disruptions. Fmea promotes proactive system thinking rather than reactive response in terms of what challenges will we encounter. It's a question that we need to ask ourselves. Before you introduce a process, you need to ask yourselves, what challenges are there beforehand? What can we do to meet these challenges or to mitigate them? Ask your laboratory personnel, what activities or processes have not yet been provided when desired results? You provided the desired results. So there are processes that might be ongoing, but and you learn from these processes that have already been ongoing for some time, and now you are introducing another process, maybe another procedure, another methodology in the lab, because processes mostly are similar. You learn from this process that has been ongoing, the process that has been ongoing, so that you incorporate the Fmea process as you introduce this other new different process, so that you can prevent future redundancies or future problems, future risks in this new process or methodologies that you are introducing. When we begin a task, we all expect to encounter failure. We do not expect to encounter failure because this is what we are running away from. No one among us wants a failure, but we have to anticipate for failures. This method of thinking will give us wisdom in solving problems that lead to these failures. We can define the future by predictions. Ask yourselves and reflect. Are you able to predict a better future in your processes, especially in the lab? To predict that the future in your operations will be better or best, then in your mind, make sure that you are reflecting on potential problems that might occur and solve these problems before they occur. Then definitely there will be a better future in your operations. Once the cause of each failure is clear, you've learned about those failures and you've all known all possible failures and their potential causes, then the your team will develop actions to reduce or eliminate the failures. When developing these actions, consider questions such as, what safeguards are needed to prevent this failure from happening? What will you have to do? Or what will have to go wrong to have a failure like this happen? How can we prevent this from going wrong? So think about wrong things that might happen. And then you ask yourself, how can these wrong things be prevented? How can we change the way we do things to make sure that this failure never happens? There is also a hierarchical ratings of risk and problem solving. If a failure like this happened, how could we quickly catch and correct the problem before we quickly catch and correct the problem before the patient ended up being harmed? If the patient were harmed in this process, or by this failure, how could we minimize the effect of the failure on the patient condition? Yes, if the patient was harmed or by bad precedents that the patient has been harmed, then how can we minimize the harm or the patient condition? You've released maybe results that are not in tandem with the patient condition and supposed to be critical values, but the method, the process was wrong because there are some mistakes that you did on the way, and results are not pro-life. But you've released them. The patient has been taken to critical intensive care because of your results, and there is a follow-up on how could these things be. The patient has been given a very high dose of certain drug because of the results that you've been given. Then you come to realize you repeat the test after being called that there is kindly confirmed. You've been called. Now you are up and down to recheck and check your controls, repeat the test or do a resampling. Now, and you come to realize that these results are wrong, or it was either a machine error or a typo or something like that associated with such, or a calibration failure. Then how do you make sure that the patient is kept safe, or the harm that has been caused has been minimized? Now, this is where communication now comes in. How prompt do you make a communication? So these are things that we need to know. Now we aim. Now, if the patient were harmed in this failure, how could we minimize the effect of failure on the patient condition? Aim for corrective actions with a stronger intermediate rating based on the hierarchy suggested by the examples below. Now look at this inverted pyramid. Hierarchical ratings on risk and problem solving. So when we have high risk, we need to take stronger actions for the same. For moderate risks, we need to take intermediate actions. For weak risks or low risk, we need to take weaker actions. Corrective actions will focus on designing controls in the system that don't allow errors to occur. and rely less on any one person's actions that are strongest. So in feasibility, we need to consider also feasibility and the cost of these steps that we are taking. For stronger actions, there are things that you need to consider, especially when we have very high risks that might come into play. Are you able to change the physical surroundings so that you can avoid these high risks? That's based on risk priority numbers that we looked before. The usability testing of devices before purchasing, that's a very strong action. Before you buy an equipment, do you have procedures or protocols to test the systems or the methodologies before purchasing? We also have engineering controls. You need to incorporate engineering controls into the system. This is a forcing function which force the user to complete an action before going to the next. Yes, maybe in our platform, the results, the tests are analyzed through a multiple testing platform, and there is because of the interface system that the results are released from the analyzer into the computer, into the system, and you are supposed to validate the results before these results are released. Then the system might not allow you to validate the results because of the failure of a calibrator or because of a control failure. So you see, this is a barrier that has prevented you from validating your results. And when you've not validated your results, you are not able to report. They are not going to be to go anywhere. So you need to check, did your systems pass? Did your calibration systems pass? Did your controls pass? Yes. Did you, maybe you can, after, maybe if your controls passed and your calibrators are okay, there is a next barrier that can prevent you from releasing the results or validating them. Maybe the system can prompt you and ask you a question. Have you counter-checked your results before you validate? Then you need now to check, because these are checks and balances. Now you need to check whether your results are okay. Are they critical results? How are they before you release them? Do you need to communicate? Or if they are critical results, are you able to communicate? It prompts you to communicate to the end user, to the user, as you report, so that critical results are handled effectively and the way they are required to. Now, you need to simplify processes and remove unnecessary steps, standardize equipment and processes. You have also to use tangible involvement and action by leadership in support of patient safety. For example, leaders are seen and heard of making or supporting a change. So leadership is also key. When a change is supported from above, then people are happy because they implement some processes or systems that are being supported, and they feel that they are supported and they are empowered to implement. So we also have intermediate actions. Intermediate actions can involve increasing staffing or a decrease in workload. Maybe a risk is associated with people, the staff being overworked and they are being fatigued. How can this error or problem be solved? Then you can think of increasing staffing so that you minimize the workload, so that people are able to operate in a better environment. You need to use software enhancement tools. You modify your software so that it is user-friendly. You modify it so that it's user-friendly. Eliminate, reduce distractions. You can eliminate distractions or reduce them, because these distractions can really cause errors in the lab. There is also readback to assure clear communication. You've communicated critical results. You need to prompt for a readback. You can read maybe 42, random blood sugar of 42. Make sure that there is a readback, not 4.2. So that there is a clear communication that this is a critical result is 42 millimoles per liter, not 4.2. So you need to enhance documentation, stroke communication. So readback is part of enhanced communication or documentation processes. There are weaker actions like double checks. You double check your results, especially when there is manual entry. You double check your quality controls. You double check when on various processes and methodologies are used, you implement them so that you avoid errors. There are warnings and labels that you can use, especially when an equipment is malfunctioning, so that to avoid its usage. And many other things, especially when there are expired reagents. A fridge is not in service. Are you able to put labels or warnings so that it's not being used? Yes, when a reagent is expired, how is it kept? Is it kept in a regular fridge, or is it supposed to be discarded? No, when a reagent is near expiry, how do you store the reagents that are near expiry, and how do you use them? What policies do you have? So you need to have standard procedures on the same. If you don't have standard procedures, you need to make new standard procedures so that you are able to prevent such from happening. You need also to train your personnel. Additional study, stroke analysis on various things that, or various processes that might be of importance in the clinical lab. There is also what we call the P diagram. In clinical laboratories, we have what we call a P chart or proportional chart. And it's a statistical quality control tool that is used to monitor the proportion of non-conforming or potential defects in or items in a process over time, such as rates of mislabeled samples, test report errors, or rejected specimen. It's a type of attribute control chart. It's ideal when data is binary, e.g. pass or fail. So acceptable or unacceptable, and the sample size varies. So we have binary data here, and you need to check items that or potential or defective items or non-conforming items, either conforming or non-conforming, pass or fail, acceptable or unacceptable. It's binary. It's either this way or the other. So, or positive or negative. So when this data is in binary, when it's in binary form, then you incorporate the P charting, the proportional charting, so that you are able to analyze this data using the P diagram. This is used on the precedents that, for example, our previous experiences are known, and they can help us to work out the Fmea or new processes or methodologies that we want to install. Yes, because some systems are similar and you want to introduce a new system and you know the previous system that you have been using all along. And just now you borrow the Fmea processes, the data from the other methodology, and now you use Fmea to analyze now the new process that you are beginning to install, or new methodologies that you are beginning to install. So you have to check on the input. Inputs, mostly when we are talking about quality management systems and the phases of quality management systems, input can be equivalent to sample preparation for sample collection and also sample collection. The item or function can be the equipment that's analyzing or the process of analysis of these tests. And then you release the results, and these are in output form, and that is post-analytical. If the input is bad, then the analytical system, even if your analytical system is perfect, you'll always bring an output that's defective, where we have error states and unwanted effects. So you have to now analyze the three: the input, the function, and the output. So here, in the input, I've talked about samples and patient preparation. And in the item or function, here is where we deal with the analytical process. And the analytical process is whereby we put control factors. Yeah, controls now here comes about checks and balances, running QCs, checking whether the system is functioning well. And there are so many things that impact the analytical process. The external environment, there are changes over time, especially on controls and calibrators, and also the maintenance of equipment, there are changes over time. Yeah, customers' usage, how do you use that equipment? How do you interact with the analyzer? How you do interact as teamwork in the lab? There are piece by piece evaluation. There are so many items and processes, complexities in the lab, you know them. How do you make sure that these processes go right so that you can get the correct output? So if things go wrong here, the environment changes over time, customers' usage, those are noise factors. When they go wrong, they bring about error states and unwanted defects. So you analyze this, either failures or passes, acceptability or unacceptability, and many other binary data sets that can be obtained. The benefits of a P diagram. P diagram allows Fmea team to better understand what parameters or factors affect the correct execution of a function. With P diagram, we can select controllable factors such as the way the function is reliably executed despite of hindrances from interfering factors. Yeah, there can be interfering factors like the environment. How can you make sure that your environment is okay? Maybe the environment is hostile because, let's say, it's too hot. How have you calibrated your equipment so that it can operate perfectly well in a very hot environment? Let's say it's coastal environment. Can the analyzer be calibrated so that it can operate in such environment without maybe air conditioning or something like that? Changes over time. Yes, let's say the equipment has been able, it was calibrated maybe, it's supposed to be calibrated every 6 months. And last time it was calibrated, it was maintained done preventive maintenance was 5.5 months ago. So there are changes over time that can make this equipment malfunction. What can you do so that this equipment functions well? How do you calibrate? You can calibrate this equipment so that it can operate well. Yes, you can do routine maintenance. Yeah, you can do cleaning, internal and external cleaning, and do calibrations, the technical aspect of the equipment, so that this equipment continues to function well, irrespective of changes over time, before the service engineer comes to service it at the required time, maybe at 6 months. Yes, that's what I mean by changes over time. How are your staff equipped to operate the equipment? And what is your interaction with the team or with the equipment as you operate it? What input do you give it? If you give it wrong inputs, you will continue to make the equipment deteriorate. Like now, let's say hematology analyzer. You keep on collecting samples wrongly, and your input is mostly clotted. Okay, the samples have been incorrectly collected, and there are some clots in the EDTA samples, and continuous clogging of the system, of the tubings, will make your equipment fail. So there are so many other things that you need to look at in the lab, the piece by piece variations. And these variations can make, are noise factors that can make your systems fail. So are you able to operate well even when there are certain elements in the lab that are affecting your operations, the noise factors? The key benefits of Fmea in clinical lab is the next thing that we are going to look at. Now, in Fmea, we have enhanced patient safety. By identifying the potential failures before they occur, Fmea helps to prevent medical errors and that can harm patients. Fmea can lead to improved test quality and reliability. Fmea leads to more reliable processes and accurate test results by systematically identifying and mitigating potential quality failures. Fmea is effectively used in risk management. So, and again, it's a proactive tool in risk management. It allows labs to assess risks and assign scores. The RPNs that we looked at, the risk priority numbers, to prioritize mitigation efforts, focusing resources on the most critical issues before they lead to harm. As we head to close of this presentation, we're also going to look at the key benefits, such as cost and time reduction. And this is by preventing failures. Labs often need to rework repeated tests and costs associated with the repeating of the same mistakes. Also, teamwork and communication is also another benefit of Fmea, because it encourages collaboration between different lab functions, promoting knowledge and sharing a more comprehensive approach to risk assessment. There is also a structured improvement process. It provides a clear framework for evaluating processes, deciding where to implement improvements, and measuring the effectiveness of these actions. It's also a regulatory compliance. The documented risk assessment process supports compliance with industry standards and regulations for quality and patient safety. It can be a regulatory framework or for compliance, especially by maybe our regulator, and they can be used as by a PT, the proficiency testing providers. They can be used by our by the bodies that by certification bodies. They can be used by various stakeholders to check for compliance and also patient safety. Fmea can be used to identify weaknesses. Analysis helps to pinpoint specific vulnerabilities and weaknesses within each stage of the testing process. Now we need to ask ourselves, between Fmea and quality control, which one came first? Because quality control and calibrations are there, and we cannot separate them from Fmea. Maybe one led to another. To sum it up, we need to look at potential areas where Fmea has always been used. Let us look at the medical lab, the medical lab environment, and how Fmea has always been used. Some people might not be knowing that they are using failure mode and defect analysis, because failure mode and defect analysis is maybe it's what has derived all these operations in the lab, right? Yeah, it might have been the origin. What we usually do in the lab must have originated from Fmea. Now, Fmea is used in QC to make it possible to detect potential failures of an analyzer. Fmea, Fmea is also seen in trainings and competency testing to prevent future mistakes. Recruitment, training of highly knowledgeable staff on complex specialized procedures. It also falls under Fmea. Yeah, because these potential failures must have been thought, and that led to recruiting staff who are highly knowledgeable. Environmental controls, such as temperature, electrical systems, water quality, and air quality, etc. You must make sure that your environment is okay for your operations to be safe, to avoid errors. Testing and recalibration and method validation on equipment. Fmea has been used here. Biosafety and biosecurity to prevent infections, and staff safety and patient safety. We must use biosafety and biosecurity protocols. Regular recalibration of all relevant equipment is also key in Fmea. Increased staffing to decrease the workload is also very important as we consider Fmea. Software enhancements, stroke modifications. The software is a great asset in making sure that we prevent future errors from occurrence. And also, it smoothens our operations in the lab, especially in modern technologies. You need to eliminate and reduce distractions. Yes, because in the lab, there are protocols that must be followed for the team to work efficiently. Distractions have to be avoided. Maybe you have a rule to reduce eliminating distractions or reducing them. Read back. Remember when reporting critical resource or certain resource or verbally, sorry. We need to have enhanced documentation and communication. We need to make sure that our communication is clear, and this always has been used in the lab. Double checks are also very important when reporting. Warnings and labels, especially on things on relevant processes, methodologies, or procedures. We need to have warnings on labels, and I've stated it in previous slides. We need to check and see where there are gaps and formulate new standard operating procedures so that these standard procedures guide on how certain processes should be done. You need to perform constantly additional studies, analysis on procedures and methodologies and processes, whether they are working and how they are working, and whether we need improvement so that there is efficiency and there is a potential for reducing or eliminating errors altogether. So as we come to the end of this presentation, we have learned a lot about the potential benefits of Fmea in the laboratory, in quality management systems in the laboratory. So it's key for us to understand that this process of Fmea is very key to ensure that our patients are safe, we are also safe, and also the rest of the stakeholders are satisfied with the services that we do offer. So this is the end of our presentation. I appreciate your audience, and I'll take it back to our moderator, Mr. Fred. Thanks a lot.
Thank you, Agri, for that wonderful presentation. And indeed, it was quite an insightful presentation. Well done, well done. And I'm sure that those of us who were able to log in have been able to get something, but most importantly, that it will help us in our day-to-day practice. So thank you, Agri. It was quite well done. And maybe at this point, I'm going to invite those who want to comment, and maybe I will be able to allow you, if you want to speak. I can see your comments. Noah Kihoro saying nice presentation. Christine, thank you. And all of you who are Evelyn Nakumicha, excellent presentation. And all of you who are able to just appreciate the speaker for the job well done. So I know this is an area that needs continuous learning. And maybe at this point, I'm going to allow anyone who wants to either ask a question or you want to comment. I can give you the mic. If there is any such participant, I can give you the mic for you to be free to comment. So if there is any, kindly you can just raise your hand. I'll be able to give you the rights for you to speak, either to answer or to ask, or even to just make your comments. Otherwise, I think we want to acknowledge all the feedback that you've given in the on the chat box, and I'm sure that all of us, even those of us who have not been able to either write a comment, we've been able to gather something. So, Agri, I don't know whether you can see any question, and whether you can see any question on your end.
Let's see. moment. Let me have a look at
Yeah, I think largely their comments. Largely their comments. Yeah, it has not listed a lot of questions. Largely, Daniel, thank you, Daniel, for tuning in. Dorcas Chelanga, thank you for tuning in. I think there is no further Felix Wamalwa. Thank you, Janet Chepkorir. Very informative. Thank you, Janet, for the comment. I think that's all. Seemingly there is no further question. But if there's anyone who wants to talk, Paul, I can see Paul here. Paul, I can give you a minute. I'm sure you will not miss something to say. Paul, let me see. Okay.
there is a question here. Thank you, Paul Kahara. Thank you. There's one question here. I've been to laboratories that use two parameters when estimating risks on Fmea tables. What is the severity and probability of occurrence? Other use additional parameter detection or detectability. Kindly highlight what's important, why it's important to consider three parameters. This is a very important observation, and we remember as looking at the risk priority number. The risk priority number, we got the formula for calculation of risk priority number. That is risk priority number equals to severity, that's S, occurrence, that is O, and also detection. So there are three parameters in risk priority numbers. One is severity, and the other one is occurrence, and the other one is detection. So it's important to consider the three because you see if you use let's say for instance you use occurrence and detection and you don't use severity, maybe you get a calculation where severity is not included. When you get this RPN, it will be flawed because there are things that you have eliminated from your equation. Therefore, it's important for you to consider all the three because, yes, there are parameters that you can eliminate like detection. There are things that are detected and some of them are not detected. What about detection? How many of them are being detected? They are severe, but they are not detected. So it's important to consider all the three so that to give the risk priority numbers the weight it deserves. Thank you, Paul, for that observation. Thank you,
Thank you.
Roland.
Yeah, Dr. Evelyn Kutolo, thank you for your concern. I'm not sure whether we can be able to get the entire brief, but I'm sure those of us who are not familiar with this area, it's an area that we will keep checking. But maybe agree we can check if there are further comments, then we can see if we can do just something very small, a small outline as requested by Dr. Evelyn. James is asking, how is risk register different from Fmea, and if and is Fmea updated at any given time? So I think maybe we can you can answer that, and then we see if we can do something as an outline, and then
Yes.
we check if there's any further question.
Yes, James, thank you for that. Now, risk register different from Fmea, and is Fmea updated at any given time? Risk register is just one of the parameters in Fmea, because there are so many things that we usually operate on, especially when we talk about the risks, because there are things that come into play. And some processes are evaluated whether they're up to date, and they are robust enough so that we can be able to avoid the risks. And now, here we are talking about Fmea, which is whereby the risks, where we talked about risk priority numbers, how to evaluate risks. Risk evaluation is under Fmea, it's under failure mode and effects analysis. So there is failure detection, risk detection. This can be used in various ways, in various angles, depending on what we are dealing with. There can be a failure that is not risky, maybe to a patient, or its risk, it's low, in quite low in the pyramid of risk priority numbers. Either it's low risk, can be intermediate or high risk, or a failure that has no potential impact on the operation. Maybe someone is late. It's a process now, because someone has broken a process or laws or rules that govern an organization. This person has come late twice, maybe 2 hours late, but there is no patient who has reported. But you see, this is a potential it's a failure in the system, but no one has been put in at risk. Are you seeing that now? So it depends on which angle you are looking at. But we have here are considering Fmea to be okay. Risk to be under failure mode and effect analysis. Now, failure mode and effect analysis can be updated at any given time. That is very true, James, because there are new processes we can incorporate into an analyzer. A system that is ongoing, a methodology that is ongoing, and a system that is ongoing. We want to incorporate maybe, let's say, for example, we are using a platform that we want to link a certain equipment to this platform. And linking an equipment that is that can be able to can be adopted by this platform is a process on its own. But now we need to put it under failure mode and defect analysis. What are the risks of incorporating this? There is a software issue that has to be thought of. There are potential redundancies can occur due to interference of a new system or testing system that's being brought on board, or new reagents being calibrated into a system that we are using that we don't normally use. How are we going to handle? What are the potential effects? Are there interferences? What do they need programming or input of a new software? There are so many things that we need to look at. So thank you, James. I hope I've answered you well. Thank you, everyone, for the comments. There's another question from Jafet Kiplimo. It seems that QMS and QCs give back to Fmea. Insightful presentation. Thank you, Jafet. Thank you, Samuel. Thanks a lot to everyone. Really appreciate. Back to you, Mr. Fred.
Thank you so much, Agri, for job well done. It was quite a wonderful presentation. And on behalf of all the participants who were able to just join in, I want to say thank you from our end as LMSK. And I'm sure these are areas that we should keep checking and improving. And I'm sure that wherever we are practicing from, these sessions are not just here for CPD points, but they are also helping us to improve our practice. So I'll take this back to you, Agri, for your closing remarks, and then we can bring this to a close.
Thank you. In my closing remarks, maybe I will say that we generally it's a human limitation that we cannot be able to predict the future, but creating a good predictable future is in our hands. So this is a paradox in life. However, Abraham Lincoln, one of the greatest presidents of the United States, said, the best way to predict the future is to create it. Now, for me, I would like to say that you create a future by anticipating problems and you solve those problems beforehand. Thank you. That's my parting shot. Thanks a lot, LMSK.
Thank you, Agri. That was quite powerful, and I'm sure majority of us practitioners will be able to predict the future. So at this point, colleagues, allow me to bring this to a close. It was wonderful hosting all of you. And until next time,